Okay. Today's topic is AC fundamentals. It comes under a module of AC analysis. In this AC analysis, AC fundamentals, average and RMS values, steady state analysis, construction of power triangle. All these topics comes under AC analysis. Undoubtedly, AC analysis topic is tougher than DC analysis. DC analysis easy because signal is simple to understand. AC analysis tough because AC signal itself complicated to understand. It contains so many parameters, peak value, peak to peak value, then time period, frequency, average value, RMS value, form factor, peak factor, and so on. So all these things applicable to signal. So you have to understand all these parameters to understand the AC signal. Not only that, for DC signal, capacitor simply open, inductor simply short. But for AC signal, capacitive reactance, inductive reactance, impedance, phasor concept, power factor concept, and so on. All these things will come in this topic. So we should know all these things. That's why AC analysis is tougher. And all of you listen carefully all these fundamentals and all the topics. And also don't forget to subscribe my channel CH Ganapathi Reddy bracket CGR. So let us start the topic AC fundamentals. Any signal is characterized with amplitude, frequency and phase. So if I take a signal f of t, we write it as a sine omega t plus or minus theta. So this is amplitude, this is frequency, this is phase. So any signal characterized with amplitude, frequency, phase. We can use sine or cos, don't worry much, but generally we prefer sine because it starts with the zero value when t equal to 0. So basically this A is amplitude. Or peak value of the signal. Peak value of the signal or maximum value of the signal. Then omega is angular frequency. Angular frequency. Units are radians per second. This is equal to 2 pi f, where f is a normal frequency. Units are cycles per second or hertz. And this is also equal to 1 by t. And this t is time period. Units are seconds, or it can be radians, or it can be degrees. Generally, we say in seconds, But we can also convert into radians or radians into degrees or radians or degrees into seconds. General units are seconds. Then theta is the phase. The phase is measured again radians or degrees or even in seconds. If it is plus theta, he is leading. There are different names for this: advance, or before, earlier. If it is minus theta, he is lagging or delay or later or after. These are the similar words. So I just given the name of each, but what is the meaning of each you have to understand. I will explain from the bottom to top. Let us start with theta and so on. To understand the theta, so let me take one example. Two persons, X and Y, are walking on the road. Road is not moving, persons are moving on the road. So they are going like this. So who is leading? Obviously, Y leads. Y is before X, so clearly Y leads. But the same way, you can't apply concept on the signal. So this axis is time. Let us say this is signal A, this is signal B. So which signal is leading? If you apply similar concept, you think that B is leading, signal B is leading. But actually signal A is leading. Why this concept cannot be applied on this? Here what is this? Distance. Here what is x-axis? Time. So they are different. Now in a time sense, leading is defined based on the signal which is touching time axis before, advance, earlier is called as leading. So signal A is touching first. And don't apply your intelligence like this or B is touching first. If you take negative, A also you should take negative. Both negative, A touching first. Both positive, A touching first. If you take one positive, one negative, you will get wrong concept. So it is based on the signal which is touching time axis. First is called as a leading. Parents are leading. Why parents are leading? Because they come to this world first, then children will come. So in the time sense only we are talking. So therefore, in this case, A leads B is equivalent to say that B is lagging by A. Plus theta is leading, minus theta is lagging. For understanding better way, I take one numerical example. F of t is 10 sine 30t plus 30 degrees. plot the signal, and mark all the values. So we can understand so many things with this example. So let us take y-axis. X-axis. X-axis is time, because we are plotting with respect to time, f of t. We are plotting f of t, so obviously x-axis is time. Now 10 sine 30t plus 30. Plus 30 means what? Leading. Leading means advance. So it should start before. Comparing with 10 sine 30t, 10 sine 30t plus 30 will start before. Before how many degrees? 30 degrees. So you need to plot like this. And it will go to peak value of plus 10, negative peak of minus 10. So what is peak to peak value? Peak to peak is 20. Peak to peak is 20. So what is this 10 indicates? It will go to positive peak of plus 10, negative peak of minus 10, peak to peak of 20. Some students, they show plus 5, minus 5. So peak to peak of 10, like that they understand. It is because of CRO effect. In the laboratory, in the CRO, generally we measure peak to peak. So they think that this 10 is peak to peak. It is wrong concept. Now at t equal to 0, what is sine 30 is 1 by 2. 10 by 2 is how much? 5. So we have to show here 5. Then time period from here to here. So signal started here. From here to here, it is the time period. Time taken to complete one cycle of the waveform is called as a time period. How to find this time period? What is the omega value given in the example? 30. So 30 equal to 2 pi f. Therefore, 2 pi by t. What is t from this? 2 pi by 30 equal to pi by 15. What is this pi by 15 value? Don't substitute 180 here. It is 22 by 7 by 15. So this, if you simplify, you will get 22 by 7 by 15. 0.21. 0.220 or approximately 0.2 seconds. So this is the time period. Like this, we find the time period. Next, we have to show this value. How many degrees leading it is? 30 degrees now. So I can't show minus 30 here. Degrees we have to convert into seconds. How to convert degrees into seconds? 360 degrees is equivalent to a time period of 0.2 seconds. But how many degrees earlier? 30 degrees. Equal to how many seconds? So 30 by 360 into 0.2 is equal to 30 by 360 equal into 0.2. Thirty by 60, 360. Into. So this is 0.016 seconds. It's very small value. So how much here I have to mark? Minus 0.016, this point. So these many seconds signal will start earlier, comparing with what? Comparing with the 10 sine 30t plus 30. Comparing with the 10 sine 30t, this signal will start 0.01 seconds earlier. That is the meaning of this. So total is 360 degrees. 360 equal to 0.2. 30 degrees, how much? Like this we convert into seconds. So we got everything now, all the details. So we understand the meaning of 10. We understand if you go here, plus theta minus theta. Yeah, okay. So here theta understood, plus theta minus theta, theta. Theta means phase. Phase means with which getting started. With which getting started. So one X person lifestyle, daily wake up at 6 o'clock. Y person daily wake up at 7 o'clock. So Y point of view, 7 is is day begin. So with which getting started is day is called as a phase. But comparing with the scheduled day. If we start early, leading. If we start late, lagging. That's the meaning of this. So T is the time period, time taken to complete one cycle of the waveform. F is the frequency, number of cycles per second. What is our Indian power supply frequency? Indian power supply frequency is 50 Hz. 50 Hz. That means in 1 second gap, it is completing how many such cycles? 50. In 1 second, it is completing 50 cycles of the waveform. That is the meaning of F. A anyway explained. Next, omega. Omega is the angular frequency. To understand angular frequency, we should concentrate on signal production, how signal is generated. To understand omega, let us concentrate on the signal production, how signal is generated. So let us start with taking a north pole, one north magnet, then south magnet. The magnetic flux will flow from north to south. These fluxes flow from north to south. These fluxes are not visible. They are just a force of lines. They are not physically visible. You can't see electron, you can't see hole, you can't see current, you can't see flux. All these things not visible. So let us keep one conductor A and A prime. So this is one conductor. And we are rotating this conductor in this direction. We are rotating in this direction. So when it is in horizontal, what is the voltage across A dash? Voltage across A dash is not maximum, it is minimum, that is 0. Why this is minimum? Maximum flux passing, but rate of change of flux is minimum. Therefore, voltage across A prime is 0. It is based on this law. E is equal to N d phi by dt. So quantity of EMF depends on number of turns and rate of change of flux. Rate of change of flux. Maximum flux passing, phi is maximum, but d phi by dt is the change. D phi by dt is always change. So change is minimum, therefore voltage is 0. So therefore, when I draw waveform, how this waveform we can plot. Here I am taking omega t. F of omega t. So it starts with 0, when horizontal 0. When this is coming vertical, few flux passing, but rate of change is maximum, maximum voltage will come. So horizontal 0, then it will go to maximum value. Then again horizontal come to 0. Then again reverse, vertical, it will go to negative maximum. Again go to 0. So this is one sine wave. When conductor is rotating under this magnets, north pole and south pole, horizontal 0 voltage, vertical maximum, again this side A dash, again horizontal na 0, then downward A, upside A prime, again negative maximum, again same position 0. So this is the signal. I can write it as FAA prime equal to A sin omega t. A sin omega t. A is the peak value. Now if we place another conductor B dash, another conductor B dash. So here how many degrees separation is? 120 degrees. So minus 120 degrees. We are placing another conductor B dash with 120 degrees apart. Voltage across B dash is also sine wave. Voltage across A dash also sine wave. Only phase difference is 120 degrees. Negative means lagging. Lagging means it will start later. So this is 0. This is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. 120 na, so it will start somewhere here. So here I have to draw another sine wave. So this signal is FB dash equal to A sine omega t minus 120 degrees lagging. Like that, third waveform, now let us keep another conductor C prime. How many degrees here? Again another 120. So this is minus 120. Minus 120, minus 120, effectively minus 240 clockwise direction, anti-clockwise direction plus 120. So where it should start? Minus 240, 180 and 60. So it should start from here. So this is the third waveform. FCC dash equal to A sin omega t minus 240 degrees. We can also write it as A sin omega t plus 120. Both are equal. So this is a three-phase waveform. Three different colors I used. Now you understand how three-phase waveform is generated. Voltage across A prime is sine wave, B prime also sine wave, C prime also sine wave. Amplitude value same, frequency same, shape of the waveform also same. Only difference is phase difference of 120 degrees each. How this 120 is coming? 360 by 3. Three conductors na 360 by 3 equal to 120 each. So like that we got 120 degrees separation. Now to understand the meaning of omega, what is omega given? 30. What is this 30 radians per second? What is the meaning of this 30? It is completing 30 radians in 1 second time. But to complete one round, it is 2 pi radians now. So to complete 2 pi radians, how much time it will take? So that is nothing but 2 pi by 30 into 1 is equal to again pi by 50. So omega is the angular speed. The meaning of 30 is it is rotating in every 1 second 30 radians. But to complete one round, 2 pi radians equal to how much? This pi by 15 earlier also we got same answer. Na? That is by formula. This is by concept. Pi by 15. If it is rotating, if omega value is more, means more angular speed. If it is more angular speed, time taken will be less. So that is the meaning of omega. Sometimes we plot signal in time, sometimes omega t. What is the difference between these two? When we are plotting in time, the time information is available. Omega t is the generalized. For example, if I plot signal like this, it is omega t. What is omega t units? Radians. Radians. So this is pi radian. Here 2 pi radians. And this peak value A, this peak value minus A. If I draw expanded version like this, here also pi and 2 pi only. But time for this not same, but always we are showing pi 2 pi only. So omega t scale is a generalized representation. Time scale is more specific. So time information is not available. I can give another example. If rope length is like this, now hold here and go around. We go like this, the time you calculate. Then increase the rope length. Increase the rope length. Again go around. Is this time same? Time will be different, na? So time for this different. If you plot in time domain, this difference is known. But if you plot in omega t, here also you are showing 2 pi radians, here also you are showing 2 pi radians. So showing signal in omega t is not a, it will not give a clear information. That is the difference. So with this, I explained the meaning of all. Let me explain some more general information. We come across single phase system, two phase system, three phase system, four phase system, and so on, n phase system. Practically single phase, three phase only popular, two phase, four phase, all these phases not popular. Light load below 3 HP, single phase is sufficient. More than three phase, more than 3 HP horsepower, three phase supply is necessary. If load is less, single phase sufficient to rotate the rotor. If it is heavy load, single phase cannot rotate the rotor. If you go for two phase, it is 360 by 2 equal to 180 degrees. So one phase rotate 180, other phase rotate another 180, and rotation will not be smooth. Because rotation is not smooth, we don't prefer this second phase. To improve the smoothness, we go for the three phase. Three phase advantage is 360 by 3, so 120 degrees each. Smoothness is improved. If we go for four phase, more smoothness will come, but the generation cost will increase, transmission cost increase, distribution cost increase, motor winding complexity increase, repairing cost will increase. So cost is increasing from four phase, five phase, and so on. Two phase is cheaper, but because of inconvenient, we don't use it. And with three phase, we are comfortable. We don't want more comfort by spending more money. Reasonable comfort level we reached with the three phase. That's why three phase is single phase. Only these two are popular. So any motor, either single phase or three phase, available anywhere in India. So that is about the phases. Now coming to the transformer, any transformer, what is the function of transformer? Transformer will transfer the power from primary to secondary. So this HT line, HT means high tension, order of kVA, kilovolt, kV. Then transformer rating is kilovolt ampere. Then output will have again phase 1, phase 2, phase 3. Phase 1, phase 2, phase 3, three phases, high tension. Then secondary side LT line. LT means low tension. Low tension means 230 volts. This 230 volt is RMS. Also it is called as a phase voltage. Phase voltage. Phase voltage means voltage in the line with respect to ground. So there is one more wire will come which is physically connected to ground. It is called as a neutral earth or a ground earth. What is the voltage here? 0. So this is phase 1, this is phase 2, this is phase 3, this is neutral. Phase 1, phase 2, phase 3, and a neutral wire. What is the difference between ground and earth? Earth is a planet. Surface of the earth is the ground. We connect this wire to the ground, but ground is a part of the earth. That's why we call this as a ground or earth. But potential is always 0. So secondary of the transformer will have a three phases, one neutral wire. And how this is distributed, this wire and this ground given to one village or a colony or village 1. Whereas this phase 2 and this neutral wire is distributed to another village V2. Like this, phase 3, this neutral distributed to another village 3. So in each village, what are houses will be there now? So many independent houses. So there are so many houses. Each house inside what they use? Tube light, grinder, washing machine, AC, good night mat, computer, mobile charger, etc. All these electrical appliances will run with a single phase power supply. So what is distributed? Single phase power supply only. All the equipment will run with a single phase power supply. Like that, village 2, village 3, and approximately load will be balanced. So when it is coming as a village concept, it is fine. But when it is coming as a metropolitan cities, in metropolitan cities, they are constructing so many apartments and so many floors and so many flats. So maybe floor 1, floor 2, floor 3, etc., floor 30. So somebody purchase a flat here, and inside again tube light, fan, AC, etc., all will run with single phase power supply. But how they get the water? If it is a village concept, there is one overhead tank with the gravity, all will get water, and all electrical appliances will run with a single phase power supply comfortable. But when it is coming as a this apartment culture, with the gravity, water will not go to 30th floor level. So what is the solution? A builder will dig another bore a depth of 1000 feet or 1500 feet. He use some 5 HP motor or 7.5 HP motor or 10 HP motor. This motor need 3 phase power supply. So phase 1 given, phase 2 given, phase 3 given. For motor, neutral not necessary, phase 1, phase 2, phase 3. So this motor will run, then it will lift the water. So they construct some overhead tank here and water will be filled here. And if you release the taps, then all will get the water. So to run this motor, compulsorily we need 3 phase power supply. Because of this problem, compulsorily builder go for another individual transformer. Again phase 1, phase 2, phase 3. Again phase 1, phase 2, phase 3, neutral connected to ground. So phase 1 given to here, phase 2 given here, phase 3 given here. So motor will run, water will come. Now, so water problem is solved with this. Now what happens, this power distribution in each flat, 3 phase power supply given or single phase power supply given? I know you will tell single phase power supply. What I am telling is 3 phase. The problem is if phase 1 given this floor, phase 2 given second floor, phase 3 given, third floor, like that distributed. A final cricket match going on between India and Pakistan. Suddenly, power in phase 2 not there. So this is dark. What is the problem? Second floor, all these people cannot see the TV, but first floor, third floor, they watch the TV. The problem is if power is not there in whole building, all will be happy. And here problem is some floors power is there, one floor power is not there. So they feel bad about it. Because of that problem, what is the solution? Three-phase power supply is given to each flat. Within the each flat, phase 1. So any flat, master bedroom, then children bedroom, then kitchen. Okay, kitchen and all, phase 3 given. Children bedroom, phase 2 given. Master bedroom, phase 1 given. So phase 2 power not there means children bedroom only power not there, but other areas power is there. Na? That means any phase power not there means 1/3 portion of the house only affected and 2/3 portion of the flat power is there. That means discomfort or inconvenience is optimized by with this. So every flat to every builder compulsorily three-phase power will be given. They use three-phase meters only. Three-phase meter tariff plan is higher comparing with the single-phase meter. Single-phase meter tariff plan is less. Three-phase meters tariff plan is more. Government also will get more revenue with this. It is a mandatory rule. Every flat, every builder, compulsorily they have to give three-phase connection. They have to install three-phase meters. So total load together considered when they are billing. So this is the importance of phases and transformer. Now, what is the importance of 3-pin plug? Every house we have a 3-pin plug. Here bigger hole, smaller hole, here small. Now let me take example of iron box. Iron box. So internally there is a filament. Let us say this is 230 volts. 230 volts phase voltage. Line voltage means voltage between two lines. Voltage between two lines is line voltage. Voltage in a line with respect to ground is a phase voltage. Our Indian standard 230 volts RMS phase voltage. If this is phase, this is neutral. So this wire connected here. This is transformer earth. This is a transformer earth. Transformer earth. So this point is connected here. Now when it is connected to iron box, current will flow like this through filament, again come back. What will happen? Suddenly this filament touched the body of the iron box. So when you are doing iron, there is a possibility that you may touch this. We are standing on the ground, so you may touch this body. But internally filament touch. It is by fault. So indirectly you are touching this body touched to filament. So you are fingering in 230 volts. So current will pass through your body. How much current? Current here is 230 volts by body resistance. So example 100 ohms. So 2.3 amps current flowing through your body. This is high current. 2.3 amps is very high current. Then what is the power dissipation in the body? 2.3 square into 100. So much of watts. Whatever power is dissipated in the body converted in the form of heat. Because of heat, temperature will increase. Earlier blood is liquid form, now it will become solid form. Heart is pumping blood, but blood cannot move. So you will die. You will die. So shock because of current. When current is coming, shock because of heat. Getting shock. Somebody got shock means heat. Heat because of power. Power because of current. Current because of voltage. Okay. How to solve this problem? So this point is a local earth. This point is connected to body. Now we are calling this as a local earth. Local earth. So any builder, when they are constructing the flat, they keep GA wire in the wall. That GA wire will come to here. That is in the wall. Wall is connected to earth. Na? So again, it is a zero potential. This is also zero potential. This is also zero potential. Now this zero is connected to body. If filament touched the body, body contacted to ground. So now current will take which path? This is a zero resistance path, 0 ohm, whereas human body is having resistance of 100 ohms. So comparing with 100 ohms, zero resistance is less. Current will not pass through body, current will pass through this wire. Then you are protected. So whenever some fault is there in the load, with this 3-pin plug mechanism, human beings are protected. That is the advantage of 3-pin plug. We generally use 3-pin plug for iron box, washing machine, geyser, AC, grinder, etc. Where load is high and where human being is touching. Tube light fixed in the ceiling, so we don't go for 3-pin for tube light or a bulb. And electronic, any electronic appliances, computer, charger, all these things, 3-pin not necessary. We don't get any shock. 2-pin is sufficient. But Nokia charger is using 3-pin plug because of heavy weight. When weight is more, when they are using 2-pin, the charger may fall down. And even though phone is working, charger break, not working, then you are in trouble. The solution for this is they manufactured with the 3-pin. The 3rd pin is helpful not to fall. The charger will not fall down. It will give a better grip. For that purpose, Nokia charger is having 3-pin plug. But nowadays they are also realized to manufacture lightweight. Samsung, LG, Nokia, all are nowadays manufacturing 2-pin only. So in general, any electronic low power, 2-pin sufficient, high power, where there is a scope of touching the human being, there they go for a 3-pin. Within this 3-pin plug, third pin is thicker and longer. Why thicker and longer? If it is thicker, because short circuit current is high value. This high value should go. If it is a thin, because of high current, if that pin is spoiled, then when you go and touch, you will die. So what is the best safety? Thicker. Not only thicker, it should be longer. If it is a short length, when we plug in 3-pin, if there is a scope, it might not contact properly internally. So to ensure it is contacted perfectly, then longer pin is used. So everything there is a science behind. The small holes dia also there is a logic. A child A child when started walking, children may keep their fingers in this hole. So old dia is designed such that a 5, 6, 7 years child, little finger should not go inside. Little finger should not go inside. Those days, that is an idea. Nowadays, some backside plastic protection is coming, no problem. But initially, uh, long ago, that is the reason why or how they selected dia of the whole. Okay. Now some more concepts. AC source should have a plus minus or not. This AC source plus minus. This plus minus we should have compulsory. This plus, some students think that AC source means sine wave. So sine wave always positive, negative, positive, negative. So positive, negative continuously changing. There is no meaning of, there is no sense of showing plus minus. But the correct answer is we have to show plus minus. This plus is not this positive cycle. This minus is not a negative cycle. Plus indicates positive phase. This plus indicates phase. This is plus. This is plus. This is plus. This is minus. When you are touching plus, you will get shock. When you are touching at minus, you will not get shock because minus is 0 volt. Na? Plus indicates the phase. It is a live wire. It is a power supply. Minus is neutral. So compulsory AC source also we have to show plus minus. And if this is given to a bulb, filament type bulb, and if it is connected like this, now 100 watts bulb example, voltage of 230 volts, in Indian system 50 H. Now current will flow. Na? How much current will flow here? This current is 100 divided by 230. This is the current flowing through filament, again coming back. How much current will come back? Again same, 100 by 230. Now, what is this one is 0 potential, negative, plus means 230. Now, when your person standing on the earth touched this wire, will he get a shock? He will not get shock. Why he will not get shock? Current will not flow. Why? Standing on the earth means 0 voltage. What is the voltage here again? 0. 0 minus 0 is 0. Current will not flow. So this current is flowing through this path only. This current will not take via human body because human body resistance is 100 ohms. Na? That is the reason. Thankful to God, human body resistance is 100 ohms, but this path resistance is 0 ohm. That current always take that path only. It will not go through human body. We are safe. But if same wire connected to here, what will happen? Here 230 volts. Here 230, other side 0. Now current will flow. You get a shock. You get a shock. Shock because of current, but current will come with voltage only. Without voltage, you don't get current. So what is the point here is, even though current is same both the wires, when you touch 230 volts only, you get a shock. When you touch 0 volt line, you will not get a shock. That is the point. I can give another example. A iron cot with iron legs. All legs are contacted to earth. Now somebody is sleeping on this cot. Now 230 volts wire you connect to this iron cot. 230 volts wire contacted to this iron cot. Now this person, will they get shock? Yes or no? He will not get shock. Why? Head is having 230 volts, leg is having 230 volts, whole body, every point is having 230 volts. Potential difference is zero, current will not pass through body, therefore you are protected. Now ask him to get down. When you are asking him to get down, as soon as he touched the floor, then potential difference will establish, current will pass through body, then you get a shock. These are all simple, funny things you should know. Next, what is the difference between Indian system and American system? Indian system, we have a 230 volts, 50 hertz. American system 110 volts, 60 hertz. Low voltage, high frequency, high voltage, low frequency. So what are the advantages, disadvantages with each? One immediate difference you can notice when you are in India. When you touch this 230 volts by standing on the ground, then current will pass. How much current will flow through human body? This current is nothing but voltage is 230. I equal to V by R na, 230 by body resistance. And so 2.3 amps current flowing. The same person standing on the ground touched this 110 volts. How much current will flow? 110 volts by 100 is 1.1 amps. Here 1.1 amps, here 2.3 amps. Na? Which case more current to Indian case? Who will get shock, severe shock? Indians will get severe shock. So more risk is involved in India comparing with America. That is one difference. Second difference is, let us connect 100 watts bulb. Bulb is 100 watts. Voltage applying 230 volts. So how much current will flow here? Is 100 watts by 230. Voltage into current is power. Na? The same way, same 100 watts. Here 110 volts. What is the current here? 100 watts by 110. Now which case more current is flowing? In American system, more current will flow. Indian system, less current will flow. More voltage, less current product is 100. Less voltage, more current product is 100. Because both the places we have to run 100 watt bulb only. Na? So power consumption is same. Voltage is different, current also different, but product should remain same. To send more current in American system, we need thicker wire. Thicker wire is costly. Thinner wire is cheaper. So in Indian system, customers are spending less money, whereas America, customers are spending more money. Government is spending less money because of low voltage. Indians government is spending more money. Government more money, customers less. America government less money, customers spending more money. So more plus less is equal to less plus more. Energy neither created nor destroyed. Somebody should pay from the pocket. So that is another difference. But bulb glow point of view, India or America, same only. We are also consuming 100 watts power, both the countries. Now, why this is second difference? Third, why this 230, 110? Why this difference? Those days, there is no communication between the countries. Globalization is not there. So independently, power developed, voltage developed. Value of voltage depends on N d phi by dt. So 230 volts or 110 depends on number of turns and rate of change of the flux linkage. Now more voltage in India means more number of turns. More number of turns, more voltage is coming. Whereas America, N d phi by dt, they used less number of turns, generated low voltage. But when turns are less, lightweight, they are able to rotate the conductor fastly. Therefore, they can go up to 60 H. Whereas Indian system, more turns, more weight, they rotated conductor up to 50 H only. So high voltage, low frequency, low voltage, high frequency. High voltage, high frequency, very, very tough. Low voltage, low frequency, easy, but no use. High voltage, low frequency optimum, low voltage, high frequency is optimum. So Americans, because of lightweight, they could able to rotate the conductor further higher speed. So 60 Hz, Indians only 50 Hz. What is the significance of this frequency again? For example, same 230 volts, if frequency is 1 Hz only applied, what is the problem? 1 Hz means to complete this one waveform, one cycle of the waveform, how much time it will take? 1 second. So what is the bulb status at this time? Bulb is off. Here bulb is fully on. Again fully off. Again completely on. Again off. This will come in next cycle. So in one cycle, 2 times bulb fully on, 2 times fully off. So bulb brightness is varying. And if you want to read under such bulb, practically not possible. Now if you increase the frequency to 2 Hz, then 4 times bulb on, 4 times bulb off. Even still you can't read. But if you go up to 50 Hz, then 100 times bulb will on, 100 times bulb will off. So many times bulb on and off in 1 second time. And we are cheating our brain. Brain is innocently thinking that bulb is always on, then we are able to read comfortably. So our comfort level reached with the frequency of 50. But they want to be more comfortable by increasing frequency further to 60 Hz. Now you read in India for 1 hour, the strain on high will be more comparing with the American system because of more frequency. So these are some of the differences between Indian system and American system. At this time, we can't adapt to their system. They also cannot adapt to our system. If they change, then all the equipment we have to throw in dustbin. Manufacturer should manufacture again with the new reference voltage. again we have to purchase our, no country currency will accept, budget will not accept. So now we have to go by this only. There is another point. Any product you purchase in USA, use in India. So they manufacture American product, some product you purchased in USA. But what is the rated voltage? 110. That is designed at 110. But if you use in India, when you apply 230 volts, switch on, within no time this item will go. Imagine some grinder. So grinder somebody gifted to you and you are using in India but manufactured in USA. When you apply 230 volts, just to switch on, immediately grinder will go. So what is the solution for this? Solution is you have to use one step down transformer. So our Indian system 230 volts, then step down to 110 volts, then use the grinder, then it will run safe. It is reverse. You want to use Indian grinder in America. So there you have to use step up transfer, step up. But what is the voltage available in USA? 110. And step up to 230 volts. Then use our grinder. It will run. So these precautions you have to take. Now, which grinder is more safe? Practically, what is happening is any item manufactured in USA, that country policies, they maintain voltage perfectly constant. Perfectly constant. So when our grinder using in America, they are perfectly maintained 110 volts, 230 volts also perfectly maintained. Then this grinder is more safe. Our grinder in America is more safe. If USA grinder using in India, Indian government may not, never maintain 230 volts constant. Suddenly it will go up to 260 also, or it may come down 200 also. Because of this variation, 110 may go up to 130. Then this grinder will go. Okay, so that's why our grinder used in America more safe. American items, grinder, juice maker, any item if you are using in India, they go within 5-6 months. So tell them don't bring any electrical appliances. If they have a money, give account details, they transfer money. You can buy Indian product. So this is another interesting point. So these are some of the basics, AC fundamentals. Okay, so you in any exam they don't ask, but as a electrical engineer or when you are studying networks, these basics you should know. So with this, AC fundamentals are over. Main important how the signal, meaning of all these things, concept of this, how to plot the signal, and so on. These things are important. Okay. Now I stop at this moment.